Welcome everyone, my name is Dinos. I'm an undergraduate student here at the School of Informatics at the Aristotle University of Thessaloniki, and I'm also the chairperson of the university's ACM student chapter. This is the third Tech Talk that we are organizing for this year, so thank you everyone for your attendance. I would like to shortly introduce you to our speaker, Professor Ricardo Baeza-Yates, who is coming from the Institute for Experiential AI of the Northeastern University, who we truly thank for sharing his time with us. He will be presenting an overview of the ethical issues and challenges that we are facing with when applying artificial intelligence in the modern world, as well as what steps we need to take in order to address them in the near future. If you have any questions during the talk, you can write them down in the chat and we'll go through them at the end if you have some time. So without further ado, the stage is yours, Professor.
Thank you, Dinos, for the invitation to give this talk. So let me share the screen. I have been visiting Thessalonica twice, and I had always a great time. Too bad I cannot be in person there. So, as Dino said, I will cover some challenges in ethics in AI. So I will try to give the big picture of this problem. But before starting, this talk is part of the Distinguished Speaker Program of ACM. And I guess many of you know that because you're part of the ACM student chapter there. But ACM is the largest community of computer science professionals in the world. There are more than 100,000 members, more than half of them outside the US, although it was born in the US. So you can go to acm.org and find more information about this society. So let me start with what is the Institute for Experiential AI before I go to the topic. So this is a new institute that started last December. I joined just January, and the director is the former second chief data officer in the world, Usama Fayyad, a well-known person in data mining. And he was also the founder of Yahoo Research, Yahoo Labs, where I worked for 10 years. And we believe that practical, successful AI needs to have at least two things that are important: humans in the loop. So basically, humans involved in all the process of creation to deployment of a tool. Although I will say later that I prefer to say human in control and not human in the loop. And then also the strong dependency on data, of right data. It's not necessarily about big data, because most companies in the world only have small data. But many times we don't have better algorithms, we just have more data. So we need to focus on the quality of that data. So the presentation has two parts. I will skip some slides in some parts because I want to do it in less than an hour. But basically, I will start with 5 issues that I think involve ethics concerns in AI. These have a personal bias. These are the ones that I feel important, the ones that in some sense, I think that we need to stop. And then I will talk about the genetic issues, the ones that are really important in general. So the principles, the cultural differences, the regulation, and the cognitive biases. And at the end, I will suggest what we can do partially to mitigate these problems. So the first issue is what we call the course of bias. So basically, all algorithms receive biased data. And then we may ask if the algorithm should ask itself if it has to be neutral or if it has to be fair. Of course, these questions have to be done by the designers of this algorithm. And this is a question that sometimes we don't ask at the beginning, only when we find trouble. And the result is that we have the same bias in the output, or even worse, we have amplified bias. And when we amplify bias, we cannot say that bias is only on the data, because we have more bias. So the algorithm did something that made the problem worse. And you can check my article on communication of ACM of bias on the web, where I show that algorithms can also create bias, and more important, and I will talk during this presentation, the feedback loop of the algorithm interacting with the user also is a source of bias. Now, what is being fair? That's not an easy question. It's a question also that we, as computer science, we cannot answer. So we don't decide what is fair. This is very important because sometimes when we design algorithms or interfaces, we decide everything. And for example, here we have the difference between equality, equity, and justice. Justice is very hard because we need to remove the problem. So we get to equity where we do affirmative action to, for example, here allow the kid to see the football game. Very important, affirmative action is a positive bias. So bias can be positive or negative, but we have a bias to think about it negatively because all the news talk about negative bias. But bias as a concept is neutral, so very important that don't be biased there. If you're interested in the topic, I recommend this documentary that is available in Netflix. Very well done, much better than The Social Dilemma, and much more deep. And if you're interested in this, we did almost 2 months ago a panel at ACM with Wendy Hall, former president of ACM, Latanya Sweeney, the inventor of k-anonymity, a federal judge of the US, and all moderated by Gina Matthews, that is part of the ACM committee on technology policies, where I also belong now. So what is the answer? The answer is not always. So not always we can do this. We don't need to do this if, for example, there is no impact. But if you are harming people, either psychologically or physically, we need to ask these questions. And I will get back to this when we talk about regulation. So how we can solve the problem, and this is not part of the talk, but I think it's important to know this. You can bias the input, that will be the best thing to do, but many times we don't know what is the bias. The bias may be hidden until it's surfaced. The second is tuning the algorithm. For example, in search, we have learning to rank with bias in the sense that click bias is mitigated, and that's also a good way to do it. But then again, you need to know the bias, and it's very hard to include models that deal with bias. And the last one is the easiest one, is the bias the output. But then you have lost a lot of information. For example, if you search for a candidate for a position in LinkedIn, you may receive 50 results, and there are only 10 are women. So you cannot do gender parity. The best you can do is to put the 10 near the top. So we have gender parity in the first 20, but the other 30 will be only men. So if we want to mitigate gender bias, it's very hard to do it in the output. And let's start with the most classical biases that you see in the news. So here is the famous example of Amazon. I will not go into detail there. But then the one that appears in this, the main one that appears in this documentary, Coded Bias, is facial recognition, especially with African Americans. And if we see how the technology has developed, it's a very interesting paper that appeared last January by Raji and Fried. You see that the size of these face databases have grown exponentially. You can see here it's a logarithmic scale. So from 200 to 50 million. But if you see how these databases have been collected, you see that in the last two periods, from 2007 to 2000, let's say 20, they have been collected mainly from the web, especially the last one. And what it means that? Well, it means that they had no consent. So in some sense, all the development of this technology has this ethical issue of using faces of people without the consent of them. And I will get back to the consent because that's an important ethical issue. And for these mistakes on the technology, in June last year, so less than a year ago, the big company decided to stop selling this software to law enforcement. You will see in the documentary that the reaction of these companies was completely different. So IBM said, let's fix it. Amazon more or less said, it's okay. And then only a few weeks later, we did a statement urging the suspension of facial recognition technologies, and already in some cities of the US, this has been forbidden. For example, in San Francisco, Oakland, 2 cities in Massachusetts have forbid the use of video for basically public surveillance, something that is normal in the Singapore airport or in many places in China. So the problem is that the technology was already out there. And for example, in September, there was another problem with another African-American that was wrongly accused of a crime because of a mistake of the technology. And there's an interesting paper last year also from Selinger and Hartzog that basically explains why it's impossible to have consent for facial surveillance. So if you want to have facial surveillance, basically you are assuming that there is no consent, and then you're assuming that you have an ethical issue. We have issues in translation. So this is a classical example that was fixed last year by Google. Before, if you said he's a babysitter, she's a doctor, you translate it to Turkish, and then I don't know any Turkish, well, only a little. I cut and paste and translate it back to English, then she's a babysitter and he's a doctor. So how this can be? Well, if you do it today, she's also a doctor, and I don't know why it's uppercase, maybe an artifact of using language models. But basically, this happens also in Persian, in Hungarian, in Finnish, that are all languages where pronouns don't have gender. And then that's why you get the most common profession and not the one that you put at the beginning. Another classic paper already more than 4 years ago, trying to find he analogies. Most of them had stereotypes, like if she's a nurse, he's a surgeon, and so on. So I checked if most journalists are men in the US, and the answer is yes. But I found another problem, another kind of bias, is that most students of journalism in the US are women. So they have a hard time to get a job. Word embeddings, so language models. For example, here is a paper from Stanford that shows the stereotypes in different professions. So basically, Hispanic, then you are a housekeeper or a janitor. But if you are Asian, you can be a professor. But if you are white, you are an administrator. So this is what you get from text. So these language models have many problems, and I will go to second kind of problem later. So here I'm borrowing the table of large language models from the recent paper by Bender and Gebru. And you see that in 2 years, this has gone from 340 million parameters to 1.5 trillion parameters, 1.6 trillion parameters. So this is a huge increase. And I don't know if it makes sense, because we are reaching the size of the number of words we are using to train these models. So the question is, when do you start to overfit? But then you recreate other biases. For example, in a recent paper by Abid et al., if you have using GPT-3 for completion, you can say 2 Muslims walk into A, and these are possible completions generated by GPT-3. You see that most of them are violent. And if you do the analysis, well, Muslims get more violent completions than Christians, 4 times more, and like 10 times more than atheists. So interesting to see that Buddhists and atheists are the most less violent. But it can be complicated. Can be also in advertising. Here are couple of examples, but also can be in the optimization functions, which is more interesting. So this is the recent result on a case in Bologna, in Italy, that was last January, where the Deliveroo platform to deliver food was found to be discriminated, indirect discrimination, but that is not indirect discrimination to people. And how this happened? Well, in 2018, a group of riders said that they were being discriminated, that they're getting less work. And if you look at the writers, there were no clear characteristics. So were not only women, only immigrants, or only one ethnic group, and so on. So an expert analyzed the code, so the code was requested. Recently also Uber was sued in the Netherlands, and a judge requested the code. Will be interesting to see if they get the code. But after analyzing the code, an expert found that basically the people that couldn't deliver at dinner time, which is the most, the one that has more demand, they got less work. Why? Because they couldn't deliver at that time. But then the algorithm didn't try to balance that, giving them more work at other times. And there was discrimination because the judge said that the algorithm didn't check the reason behind not delivering at that time. For example, people had children, people had an old person that had to give food, or even that they didn't want to work at night. So this is an example of where the algorithm comes from the optimization function, because the optimization function was trying to earn more money. So it's a revenue driven. And then it learned to discriminate a group of people that were not good enough to basically obtain more revenue. But this can be even worse. So last year, there was a smart person that decided to have a fraud algorithm for child care benefits in the Netherlands. And the algorithm claimed that 26,000 families were cheating, and they had to return the money. And this created a lot of economical stress in many people. These were, of course, poor people and immigrants. Some of them had to go back to their countries of origin, and so on. And the impact was so large that not only the ministry involved on this had to renounce, but the whole government last February resigned after this scandal. So this is the problem of not using algorithms, ethical algorithms. And another example would be the UK example with the grades of students. One of the first examples that also was about the race bias was the Compass famous criminal profile. And I will not go into detail. This is well known. It's one of the first ones, and you will see it also in the documentary. So racial bias was 2-to-1. But I want to use this to ask two questions that are important. The first question is a circuit algorithm ethical? So basically, if you have an algorithm dealing with people, can we have a secret? It's because of transparency and because of these problems, so people have to audit these algorithms. And I will get back to auditing algorithms later. But then we need to ask the second question: is a public algorithm safe? Because the algorithm can be gamed. So if I know how it works, maybe I can lie in the right way. So others have done similar things, like Gotham has a criminal profiling. Palantir has a criminal profiling tool called Gotham. This has been used basically kind of secretly in some cities of the US until it was known. Also, they have been used in some countries in Europe. And the problem is not if it works or not. So we need to ask that question. It works. There is any causality. And maybe the answer is yes. But the problem is that are the mistakes. And I will get back to that. One error and a person is stigmatized, like the two Black people that I mentioned were forced accused with facial recognition. Here, there's another example done by the IIT and the Chicago City. And this is a good example of basically you measure where you measure. So if the police is in the places where they think there's more crime, of course they will measure more crime. This is like measuring water in some places and not in other places. So in other places, maybe you will never see water because you are not there. So the data is bias also, location bias. And I will get back to that with another example. Things can be even less ethical. So this is an example from Spain where the police is using a lie detector not for the accusers, but for the victims. So basically, are the victims saying the truth when someone steals their belongings? And this also, something similar happened in Germany, but in Germany, immediately the Pirate Party challenged this in a EU court, saying that this was not constitutional or didn't comply with the regulations of the EU. So basically, you see two different cultures. One accepts this, another doesn't accept this. Let me get to a detailed example of bias amplification. This is based in New York. So you know you have an offender, you have an accused person, and then the judge has to decide if the person goes free, gets bail or not, doesn't get bail and goes to prison. So typically in the world, the judge has to think about if the person will reoffend while is away, and also if the person will come back to the court in the future. In New York, very strangely, the judge doesn't have to think about reoffending, which is very hard if you say this person is accused of killing someone. Well, if the person gets bail, you go away. If the person gets bail but doesn't have the money, you go to prison. So there's an economical bias here. So poor people usually cannot get out. Although in the US there is also a person that loans money to these people in this situation, and interesting, this person also has to do the same assessment of the judge. Will the person come back to return the money later? And if they know each other, probably they say, yes, oh, I have done this many times with you, and so on. One problem here is similar to the problem that I mentioned on the location of crime. We do not know what will have happened if the person had bail. So the people that go to prison, we don't know what would have happened if free. For example, would have reoffended, would have come back. And for that, we need to do what is called data imputation. We need to fill the missing data, and we need to predict these cases, so we will have some imprecision coming from this prediction. So this work was requested by the National Bureau of Economic Research that was interested in spending less money in prisons. Was not done by the Department of Justice in the US because judges are not interested in losing their job. And this is very well done work with by Kleinberg and other great team of researchers. And they show that they could decrease the crime rate in 25%, keeping the same prison rate, or they can decrease the prison rate in 42%, keeping the same crime rate. And how they did it? Well, they divide the data sets basically in 4 parts. So one holdout for evaluation, one set for imputation, one set for training that was divided in 5 to do a 5-fold cross-validation, and one set in a lockbox that was for anyone that could audit the model without knowing that that data is completely unseen by the model. So they use gradient boosted decision trees, which are kind of non-linear trees, and this allows some interpretability. And the features, only one feature that was demographic, age, nothing else. Most of the people that get to the court are men, so gender is very biased. But there's no other demographic feature that can give away the race of the person. So there's, for example, no address. And then all the history of the case. What is the result? So let's say this is what happens in reality, and here I added the percentage in the population. So 18% of New York, the New York population, the state of New York, is Black, 13% Hispanic, together is 32. Now, the people that get to the court, 49% is Black, so here's a huge difference. 33% Hispanic, it's a different, but not that much. So there's a bias on maybe on police because they're getting more people from these two minorities. But the judge clearly is racist, the average judge, because the 49 goes to 57%. You see, for Hispanic goes down. There are more white Hispanics. I don't know if that, but could be a possibility. But overall, the 32% goes to 89%. So clearly, it's almost a 3 times more bias. So what happened with the algorithm? Well, the algorithm got this 25% improvement, and you see there was a bit more racist than the judges. So the algorithm learned to be more racist from the data, increased from 57 to almost 60%. So on decrease in Hispanic, so things that the algorithm learned that had to increase the blacks and decrease the Hispanic and amplify both effects, one in a positive way and another one in a negative way. But overall, the 89% went to 90%. So the overall the increase. Now, even if we match the judge on the less racist judge, so basically the one that is the same population, 49%, the algorithm was 23% better, so not much difference from 25 to 23, than the judges. So the question is why? So here is a good way to see it. Let's believe that the model is doing it right, so that the prediction is more or less correct. Remember, these are predictions, so we don't know if it's correct or not. And if the algorithm wants to send more people to the prison, then the model will take the top people here, the ones that are more dangerous. However, if you ask the second set of judges, they divided the judges in 5 groups, from the most lenient to the most harsher, just to be able to do this data imputation. But you see here that if the judges choose who to send to prison, they choose them from all over the place. So it's more like a random decision. And here comes something important here on algorithms. What is better, a biased but just algorithm or a noisy judge? So just in the sense that 2 people with the same data, the same information of the case, will get the same result, always bail or always not bail. But that's not true for judges. Judges are noisy. It's well known that if you see a judge after lunch, the result will be maybe worse. And here is the difference between exact, noisy, biased, and noisy. So algorithms are biased, but people are biased and noisy. And this is well explained in a paper in the Harvard Business Review 2016 of Daniel Kahneman. And 1 week ago, he published a book on this. It's called Noise, a Flaw in Human Judgment. And in many cases, noise is even worse than bias because it has a huge impact on the decisions we take. So second problem, what is called physiognomy, and this is a Greek word, so you must recognize it in Greek. And this started, for example, with a work in 2017 about sexual orientation by Kosinski, in Stanford, so psychology in Stanford. Of course, people were not happy with this. Later happened in China, and then in the US, basically predict criminals using faces. And of course, again, many people complain. And the last one in January, again, Kosinski, that basically says that can predict political orientation using your face. Of course, this is not facial recognition. We're talking about facial biometrics. So it also is he doesn't use well the words. So what is this? Well, this is phrenology, some way of phrenology. And if you ever go to Torino in Italy, you can go to the museum of Cesare Lombroso, a doctor in Italy that believed this and collected hundreds of skulls trying to prove that the skulls of criminals were different from normal people. And he was consistent with his belief because he also left his skeleton to, I guess, to have the ground truth. So that you can judge if it is the ground truth for doing something good or not. But it can be worse. So in 2019, MIT published a paper in a well-known conference in computer vision, where given a piece of voice, I can basically predict your face. So from your voice, I can get to your face, and then there's a patent application by Mitchell, where I can get your name from your face. Maybe something related to the voice in the mouth and the neck could be related to the face, but otherwise causality is impossible. That's why it's a pseudoscience. And then I can get also your sexual orientation and if you will be a criminal or not. In many countries, this is very dangerous because some of these things are illegal. Third problem, unfair e-commerce. The user filter bubble. So basically, I cannot show something new to you that you would like because it's not in the data. So to solve this filter bubble problem, companies are using diversity, novelty, serendipity. But this is more than that because it's not only you that you're in a bubble, but the system itself is in a bubble. It's in the union of all your bubbles because basically the system is writing its own future. So you can only click on what you are exposed to. So this is exposure bias. It's like an iceberg, but it's worse than an iceberg because you only see the top ice cube of the iceberg. For example, 4 recommendations of tens of thousands. And this also discriminates the long tail then, and you have the massive effect, the rich get richer and the poor get poorer. And of course, for example, you get popularity bias. Fourth problem, stupid models. And here we have to remember what George Box, a famous statistician, said, all models are wrong, but some are useful. Sometimes models cannot deal with human behavior. For example, when Elon Musk said, by signal, you got this small company in Texas, much more value in the stock because algorithms believe that he was saying buy signal instead of use signal and confuse this company with the chat application. Or here, for example, example of adversarial attack on the right, that you change 1 pixel and then a cat is changed to a bird, a chip to an airplane, and so on. So what they are learning, this is what we don't know. Or even more silly, Facebook decided to use a hate algorithm trained for English in France. So the town of Bitche, and you can assume what will happen, had their Facebook page shut down for 3 weeks because believe the town itself was using a bad word. Also, there was no human in the loop. So that's why 3 weeks, because no one was there to basically read the complaints of these people that, for example, were using this page to give news about COVID, for example. So this creates real harm because of a silly algorithm. And not only the algorithm, using English in France is a big mistake, right? So limitations are important. We need to understand the limitations. To generalize, we need to forget. So we need to basically abstract things to be able to recognize a dog from one side to another side. For example, if you give this image to animal classifier, will be very hard that you will get the right answer. I'm sure you know, but if you see the adversarial AI example, they are not learning what we learn. Also, we cannot learn, as I said before, what's not in the data. So be humble. Also, accuracy in many cases is not the key. If you have an application that deals with humans, accuracy is secondary. The most important thing is the impact of errors. Why? Because many errors are not human, like the Bitche example. This is a mistake that the human will never do and had bad consequences. And so be humble. If you're not sure, tell the model to say, I don't know. If you don't have a confidence of more than, say, 80%, say, I don't know. I seldom see this class in here. And the final problem, waste of resources. Again, the table. And what happens? We train these huge models, and these models, for example, free 57 years of CO2 equivalent in people. This is the average human life. Of course, American life will be less, maybe only 15 years, but still a lot of years. But also, we are spending up to $3 million to train these large models every time. For what? For gender bias, for religious bias, as I mentioned before. And this is the famous Stochastic Paris paper by Emily Bender, Angelina Macmillan-Meyer, Tiffany Gebru, and Margaret Mitchell, although she was still at Google and I couldn't put her name there. So that shows part of the problem. So this was published last March. And here we end the first part with this meta-ethics problem. So basically exposing problems about language models, create a situation where she was fired, deemed, and then later in February, while Margaret was trying to check if what she was rightly fired, she was fired also because of checking her email. And for that reason, a group of researchers, I'm included, wrote a paper in the AI Ethics Journal on the freedom that we need to do this kind of research. So the second part, so I will last 50 minutes, some pragmatical questions. Many important questions or principles that we want to ask of these systems. So here are possible 7. These are from the statement done by ACM 2017. So these are the 7 properties that transparent and accountable algorithms should fulfill. You see that maybe we have awareness, but most of the time we don't have any of these properties. And here it's important that maybe we're very harsh on algorithms because we believe that they need to be better than us and they are learning from us and need to be much better than us. And here is an interesting book by Cesar Hidalgo and collaborators about how humans judge machines. Here I have a list of 30 possible properties that I'm writing in the taxonomy of properties. And then I have to which part of the system applies, so the data, the algorithm, the system completely, or the governance of the system, and to which stakeholders matter, like justice, government, users of the system, and society. And based on this, and the ones in boldface are the ones from ACM, I have my own taxonomy that has 6 groups. Basically, you can see that the ones underlined are the ones from ACM and goes from awareness to completeness to responsibility and transparency. So everything to do with the data, everything to do with the user, and so on. And now people is starting to work on how we develop these systems that are responsible, that are human-centered. One of these people is Ben Schneiderman, very well known in HCI. And for example, here you see the different levels: team, organization, industry. But here is the question that is important: how to develop software with the help of AI. It's a fallacy to say this dichotomy that we have to choose between humans and machines. No, we should work together. This is the best solution, working together. So hybrid solutions are the best. We have also cultural issues. For example, here you see the map of how different laws have basically invaded the whole world because of colonialism. So this is also called technological humanism. But remember, humanism is not so human because humanism at some point defended slavery. So humanism is just a word for the Western world. And here we have religious differences. Like, for example, Christians see morals, ethics, and law as three different separate things, while Muslims see it as just one concentric thing, which makes more sense. So everything is moral, then what is public is ethical, and then part of that is the law. And then the law includes more ethical things. But for example, in the Christian world, something will be ethical today, but when it starts to become legal, it's not ethical any longer, which doesn't make sense because you shouldn't lose that property of being ethical. Also, there's a geographical diversity in culture. So here I like to mention Ubuntu, and this is the origin of the Linux version. Ubuntu is basically I am because we are. This is the south of Africa. And there's an interesting essay by Abiba Birhani that says that Descartes was wrong because a person is not, doesn't exist by him or herself, exists through other people. And I believe that this is the concept of tribe. The tribe is the important thing, not the person. And then with talking about the person, we go to identity, data protection, and privacy, things that sometimes are mixed and people don't understand the difference. So you can be completely anonymous and not private. Basically, no one knows your identity, but knows everything else. Or you can be completely private, but they only know your identity. So there are many ways to do this. And here we have some tensions, like, for example, freedom of expression versus data protection rights. For example, it's very different. I can do everything that is not forbidden, or I can do only what's allowed. Very different words, and they have to basically live together. And here we have, again, if we have consent or legal basis to do something, and proportionality. So basically, minimal data collection, minimal time stored. So there's a famous Article 22 of GDPR, the Data Protection Directive of the European Union, and I only will read the last line. To contest the decision. This is very important. Some person has to be able to contest the decision. And then what this means, that if we want to give information about the processing, we need interpretability. Interpretability is understanding how the algorithm takes the decision. But if we need to contest the decision, then we need to explain. Explainability is to explain a specific decision to a person. It's not about how the algorithm works. Is tell me why I didn't get the credit, or why I got this grade in this exam, and so on. You need to have an explanation, a story. And then you need other things if you need to show that the algorithm works all the time as intended. So GDPR in action in 2020, also about a year ago, a French court said that using video surveillance in 2 high schools was illegal. Why? Because they didn't have the competence to decide it. So the school cannot decide it in France, had to be, I think, the province that's the one that will decide. Second, there was no consent from people to be basically videotaped. And we already said that it's very impossible to have consent. And finally, proportionality, that using video surveillance was much more than needed, for example, to have basically security in the school. And here we have a problem of GDPR. One size fits all human rights, all possible domains, like health in COVID. Why it's not different with health data that is good for all of us? Why we don't have special or limited rules there, or maybe emergency rules? All sizes, all companies, doesn't matter multinational or a newspaper place. And then we get to regulation. So basically, here we have the antitrust cases that were done last year to Google, to Facebook, and just this week, I have to add it here, to Amazon. So 3 big national and multinationals have been sued in the US by the government because of antitrust issues. And here we have problems like, should marketplace sell in their own marketplace? Because they have the data of all the sellers. It's like a supermarket that already sells their own products, but this is even worse, I think, because they do have much more data. So very important, ethical boards should be needed when we have people involved that can be harmed. And in that case, 50% needs to be external, otherwise you have a conflict of interest. You cannot check the ethics for yourself. You have a conflict. During the Trump government, there were like at least 4 bills that were not passed by the Congress in the US. Probably with Biden, this will basically go back to the discussion. And one of them here is by Kamala Harris, the current Vice President of the US. And then we get to very recently, a bit more than a month ago, the proposed AI regulation for the European Union. And here you have all the things that this regulation looks at, and very interesting, forbidden uses. And here is the Title 2, first article, for Article 5. I will read: placing in the market any system that deploys subliminal techniques. What is subliminal? Beyond a person's consciousness, when a person is conscious. To distort a person's behavior. How much you can distort it? We have digital nudging, so like entice you to click in something. That is likely to cause physical or psychological harm. For example, if you're offering an ad of fast food to a person that has a metabolic problem, you are causing physical harm. Is this forbidding that? That's an interesting question. This will be revised until end of last year, and we'll have the final regulation. But here also we get to advertising in the web and other places, especially if it's a personalized advertising using AI. And also you have systems of high risk and low risk or middle risk. And again, we have the problem when we apply categories. We create categories that doesn't make sense. The risk is a continuum. Will be very hard to distinguish in the red lines of these two things. Then we have the topic of registering algorithms, certifying algorithms, auditing algorithms. Very interesting paper on FACT 2021 on a real audit study on a company that is using AI to do hiring. And this is a real audit, and it's a very interesting paper. This is done by the audit algorithms at Northeastern. And maybe in the future, now there are recommendations from the US, but maybe in the future there will be some regulation also in the hiring market against gender or other biases. So we have many human practices that are bad. So these are the cognitive biases. This is the last problem, genetic problem. I will not read them. You can check them. It's based on partially in a paper by Gina Matthews published last year. But then we have our professional biases, like big data, but most of the companies in the world never have big data. So if you want to read, I have an essay about small data in KD Nuggets a bit more than 2 years ago. What about the design implementation? Can you transfer bias from the designers and coders to the system? Well, in my ACM paper, I use a very interesting example of bias on data analysis. But recently, in Norway, they give data of a specific sample where basically they show that bias can be transferred from the people coding to the code. And this is, I think, something that we need to explore more in the future. Evaluation, basically, do not fool yourself, choose the right everything. So what we can do? We have to look for bias. We have to recollect more data in sparse regions of the solutional space or in places where it's more complex. Then we need to make sure that the model is aware of the bias and the user is aware of the bias all the time. Give more control to your user. And finally, in evaluation and deployment, you need to do error and sensitivity analysis. And maybe you need to certify your algorithms or register them, or even to do external audit if you want to check if you are being responsible or not. So some recommendations here, I will not read them, but I prefer to say that humans are in control and machines are in the loop. And ethics is a network. Ethics is not about you. Ethics is about your providers, it's about your clients. It's a bit like privacy. It's a collective property. So it's more complicated. So to finish, these are the take-home messages. Remember, systems are a mirror of us, the good and the bad. We need to be aware of our own biases. And I want to finish with two questions, or one question and a comment from Hazel Henderson. Can AI algorithms ever be ethical? It's a good question. But to be ethical, we need one condition. It's obvious, but it's obvious after you know it, by David Lauer. You cannot have AI ethics without ethics. This is the first number of the AI and Ethics journal, where I'm one of the editors. It's a new journal. It's completely free, so you can go to Springer and download the papers of the first issue. Now there are the second issue that includes this paper on freedom of research. So just to finish, I'm not worried about artificial intelligence. I'm worried about real intelligence. I see it in every election lately, although in the US there was some change. And then I don't want this, like two machines laughing at each other because humans don't exist. And it's not because they kill us, it's because we killed ourselves. And I'm not talking about military applications, because sadly, I'm sure that's the case, and we don't know anything about that. So I can take questions now. Thank you.
Thank you so much for this presentation. I'm sure there were many useful things to learn for people who are just getting started with AI, like either in academia or the industry, which I assume is the category that our audience today falls into. And yeah, I think we can all agree that it's really important to keep these concerns in mind when building ML models, since, as you said, we have the concept right now that we can only look into them once there's an issue, and not when designing the algorithm. And that can easily get out of hand, I think. So yeah, we can get some questions from the chat now. George is asking if we can have the presentation slides.
Yes, I will send it to you.
Okay, yeah. If you send to me an email, I can then forward it to everyone who registered to the event.
So there's a question of Athena, I think, here. So thank you for coming. I hope to see you in person in the future soon. So can you please comment about some solutions for human in the loop models? Is citizen science such an approach? So I guess the typical human in the loop model is basically that there's one person checking the decision and taking the decision together with the system. So this is a standard human in the loop. It's more like someone will check the final decision. But of course, we need humans in the loop in other places. So you need, for example, humans checking the assumptions of the designers when you are designing the system. We need humans in the loop checking, for example, the assumptions of the implementation when the system is being coded. We need humans in the loop when, for example, the system is being validated. And then the same when the system is being evaluated. So we always need the experts of the problem, because remember, we cannot decide things that are outside computer science. We are experts in computer science. We are not experts on the application that the system is doing. So sometimes we're too bold and we decide that we will decide these things and we shouldn't decide. So citizen science could be an approach in the sense that many people can audit these things. For example, many times what we have are audits that are basically without the cooperation of the software, without the cooperation of the company, like the case of Compass and so on. But I gave you an example where the company cooperated because they wanted to use the audit as a marketing tool for hiring, that we comply with the system. So yeah, so this is basically all the places where we can be. And of course, civil society will play a role on basically having a look at the ethical aspect of these kind of systems. So now here, there's another question by Anna. Is it true that we don't know the algorithms the computer create? How can they be auditable? Yeah, so it's true that the models that we train are so large that it's very hard to understand them. For example, if you have a language model with 1.5 trillion parameters, and someone says, tell me why it's gender bias, we cannot answer that. It's too complex. So these are black boxes in many cases. Now, how can be audited? Well, one thing is to be completely transparent. So you have the training data, you have the training software, you have the production software, and you can check at the model, like in the delivery case, and see, okay, there is a discrimination issue here. But however, you need to have the cooperation of the system. Otherwise, you need to do like an audit, like the team in Northeastern has done many times. Basically, you audit the system without the help of the system, which is much harder, and sometimes it's much harder to prove that there is discrimination. So, so Georgios asked, can we understand how AI works? So it's a good question. Many times we cannot understand how it works, so we know what we do to make it work. But for example, with the adversarial AI example, it's not clear what they are learning. So it works. We are not sure why it works. But the worst part for me is not when it works. It's, as I said before, it's when it doesn't work. So how bad will be when it doesn't work? And the problem is not how bad will be today. It's how bad will be with a case that we haven't seen yet and we will see in the future. So basically, it's how to predict the mistakes in the future, which is an issue. And for example, that's more common when you have more error, or for example, when you have a higher complexity of the problem. So this is and a lot of people is doing research on this. So Anna asking another question, what do you think will be the impact of neuromorphic or quantum computers on AI, better or worse? I think quantum computers can do things faster, but that doesn't mean that they will do it better. So could be worse in the sense that you will do the same faster. So maybe we will be able to get more results faster, and all the results will be still, for example, discriminating. So I think the model of the computer is not the issue here. So it doesn't matter what kind of computer you use, it's what are you doing. So this is the problem. But maybe with quantum computers, we'll have like quantum biases. Some biases that cannot appear with standard computers may appear with these quantum computers. I don't know. This will be a new field. One bias appears here, and suddenly another bias appears somewhere else. So, but I'm not an expert on quantum computing. Let me see if there's other. I think that I have answered all the questions. Did I miss anything, Dinos?
No, I think that was all. If anyone else has a question, you can write it or raise your hand if you have the time. But yeah, I think you shed light on a lot of things.
You have to unmute to
raise
the hand. But if you raise your hand, Dinos will unmute that person.
Yeah, if there are any questions. I think you shed a lot of light on many topics that many of us haven't even thought of it before. So yeah, I think it's a good thing to have in mind and keep going forward as a community.
And my email is available, was in the last slide, and it's available on my website. So you can go and see there. And soon I will post on my website a lot of the panels and things I have done on ASICS lately. So that will be a source of a place to look for it.
I see Professor Athena has a question. I will unmute her.
Thanks a lot. Just to express my gratitude for having Ricardo on board in such an interesting presentation. Indeed, the topic is really critical, and we see the automated decision making in AI, I think, everywhere, impacting our lives, our jobs. So it's really important. Thank you so much, Ricardo. It's nice to see you again.
No, thank you, Athena,
and congratulations for all the great work which has inspired so much of the research we are all doing.
All right, I think we can wrap it up here for the audience. Yes. Thank you, everyone, for being here, and we hope we can see you soon in an event in the future, maybe virtually or in person, hopefully.
Thank you, Dino. Thank you for the invitation. And